All right, let's talk about Rust. You've probably heard the buzz around this programming language, right? Well, today we're going to dive into what makes it so special. It's basically challenging a huge, decades-old problem in how we write software. So let's get into it.
You see, for as long as people have been coding, there's been this classic dilemma. It's a choice that affects pretty much every single project. Do you want your code to be fast, or do you want it to be safe? Think of it like this. On one hand, you've got languages like C++. They are lightning fast, giving you total control. But you're walking a tightrope. One little mistake, and you've got a nasty memory error. Then, on the other hand, you've got languages like Python. Super safe, right? They manage all the memory for you. But that safety net, well, it usually comes at the cost of performance.
And this choice, this trade-off between raw speed and guaranteed safety, has pretty much defined how software gets built. Developers have basically had to pick their poison for every single thing they make.
And with that kind of low-level control, it is just so easy to make mistakes. And I'm not talking about small stuff. We're talking about really nasty bugs like dangling pointers. That's when you're trying to use memory that's already gone, or data races where different parts of your program are fighting over the same piece of data. These things cause crashes, they open up huge security holes, and the worst part, they love to hide until your code is out in the wild, in production. The absolute worst time to discover a bug.
But what if there was another way? A way to get the best of both worlds? This is exactly where Rust comes in, and its promise is a bold one: to completely shatter this old compromise. The whole idea behind Rust is to empower you, the developer. It gives you all the power and control you'd expect from a low-level language, but it wraps it in this incredible safety net that's built right into the compiler. You can get really aggressive with your optimizations without that nagging fear in the back of your mind.
So how on earth does it do this? Well, it's to a concept the Rust community loves to call fearless concurrency. And it's all made possible by a really unique way of managing memory that stops whole categories of bugs before you can even compile your code.
So you might be wondering, how does Rust pull this off without a garbage collector slowing things down? Well, the answer is its secret sauce, its most famous feature, a set of rules the compiler enforces called ownership. Ownership is really the heart of Rust. It's not some library you bolt on. It's a fundamental part of the language that the compiler checks like religiously. The rules themselves are actually pretty simple, but what they allow you to do is, well, it's profound. Okay, so it all comes down to three main rules. Number one, every value in Rust has a single owner, just one. Number two, when that owner goes out of scope, like at the end of a function, the value is automatically dropped and its memory gets cleaned up instantly. And number three, ownership can either be moved to a different variable or it can be temporarily borrowed. And that third rule, borrowing, that's the key. It lets different parts of your code access data without having to take full ownership. This is huge because it gets rid of all the hassle of passing values back and forth just to make sure they don't get destroyed too early. And this is where Rust's compiler, the famous borrow checker, comes in. I want you to think of it like a super strict librarian. The rule is simple. You can have as many people as you want reading a book at the same time, no problem. Or you can have just one person writing in that book. But you can never, ever have both at once. That one simple rule, enforced at compile time, completely wipes out that whole class of bugs called data races. And that, right there, is the magic trick. It's the whole point. Rust takes all those potential crashes, the ones that would normally happen in production and give you a 3 a.m. pager alert, and it turns them into compile time errors. The compiler just won't let you build the program until you fix the problem. It forces you to write safer code from the start. Okay, so this isn't just some cool academic theory. Rust's focus on safety and performance has led to massive adoption. We're talking hundreds of companies using it in production for their most critical systems. And the kinds of things it's used for, they're all over the map. You see it in super fast command line tools, back-end web services, DevOps tooling, tiny embedded devices, and even in core performance-critical parts of the Firefox browser. It's everywhere. You know, one of the most compelling things about Rust is just how versatile it is. The skills you learn building, say, a web application are directly transferable to something totally different, like programming for a Raspberry Pi. It's one language that can do so many different jobs. So, if you're getting curious and want to try it out, you're in luck. The Rust community has poured a ton of effort into making the whole getting started process as smooth as possible.
You can literally install the entire Rust toolchain. That's the compiler, its amazing package manager, cargo, everything, with just a single command you copy and paste into your terminal. It just works.
And from that point, getting your first Hello World project up and running is literally 2 commands. You just type cargo new hello_world and then cargo run. That's it. Cargo does all the heavy lifting. It sets up the project, it compiles your code, it finds any libraries you need, and it runs the thing. It's just so easy.
So here's the big takeaway. Rust isn't just another programming language, another syntax to learn. It's a fundamental shift in how we approach building software. It's a philosophy, really, one that says you don't have to compromise between safety and performance. You can have both, right from the start. And it leaves you with the really powerful question to think about. What could you create if you knew with 100% confidence that your tools had your back every step of the way?